No.
Mm, Microsoft Whiteboard. Mm, Now,
Yes,
Just
okay. So we are discussing about the active filter. Today we will discuss about the general two-pole active filter. We'll discuss and develop the transfer function for the general network for the two-pole filter, and then we can analyze that general structure to develop low pass or high pass. So basically we will discuss about second order or two pole. We can say two pole or second order filter. Okay. So what we can do, we can develop the transfer function general purpose, and then we can design either low pass or high pass filter. So in order to develop the transfer function for the general two pass filter, we can consider a general two pole active filter. So it is
স্যার এটা কোন বুক থেকে স্যার?
chapter 15, নিমান কালকের লাস্টের পোর্শনটা যেখান থেকে আলোচনা করছি, বুঝছো? চ্যাপ্টার 15 নিমান article 15.1. Okay. General two pole filter. Two pole filter. Basically, it's a simple voltage follower circuit, and then we have Y4 and Y2, Y1, Y3. This is the output, and this is so we can consider this is a and this is so this is basically a simple voltage follower circuit and constructed with 4 admittance Y1, Y2, Y3, Y4. And the analysis of this circuit is nothing new. If we apply a KCL here, KCL, what will be the equation then? If we apply KCL here, then incoming current to the node and outgoing current from this node, outgoing current from this node. So the incoming current equals to outgoing current. Incoming current is VI minus VA multiplied by Y1 equals to outgoing current VA minus VB into Y2 plus VA minus V naught multiplied by Y3. And then if we apply another KCL here, then the incoming current to this node and outgoing current to this node. Incoming current is VA minus VB multiplied by Y2, and outgoing current is VB Y4. Okay. And from the voltage follower, this is the voltage follower, is it? Huh?
Yes, sir. Buffer.
Buffer. So from the voltage follower characteristics, we can say that V naught is equals to what? VB.
GB, sir.
VB. So if we put this V naught equals to VB, then from here what will happen? We can find out VA. VA equals to V naught into Y2 plus Y4 divided by Y2. And if we compare with this one and this one, then after simplifying, we can get the V naught S divided by BIS, our target. What is this? The gain or the transfer function. So this will be Y1, Y2 and divided by Y1, Y2 plus Y4 into Y1 plus Y2 plus Y3. So this is basically the TS. So based on this transfer function, based on the value of Y1, Y2, Y3, Y4, we can easily construct the two-pole low-pass filter, two-pole high-pass filter. Depends on the Y1, Y2, Y3. Okay, so if we want to get a low pass, if we want to design a low pass, means we need to pass the low frequency, is it or not? In order to pass the low frequency, both Y1 and Y2 should be conductance, okay, so that the signal can be passed through the voltage follower at low frequency, because at low frequency we need to pass the signal. So in order to design the low pass filter, we need to consider Y1, Y2 as a conductance. Y1, Y2 will be conductance. And if the element Y4 is a capacitor, if it is a capacitor, then it will produce roll off at high frequency. Roll off at high frequency. Roll off is what? Just yesterday we have discussed that the roll off is the slope, the straight line approximation just outside the band, outside the pass band, the straight line slope is the roll off. So if Y4 is capacitor, Y4 is capacitor, and in order to produce the two-pole function, since our target is two-pole, then in order to produce the two-pole, the Y3 is also should be a capacitor. So Y4 and Y3 and Y4 will be capacitor. So if we maintain this condition, we will have a low pass filter. Then if we want to get the high pass, what will happen? According to our previous discussion, we can directly say that if we change the place of the capacitor and conductance or resistor, we can get the high pass. So if we want to get high pass, the elements Y1 and Y2, Y1 and Y2 should be capacitor. Y1 and Y2 should be capacitor. Why this should be capacitor? Because in the low frequency the signal should be blocked. Okay, in the low frequency the signal should be blocked, capacitor. And Y3, Y4 should be conductance. The admittance Y3 and Y4 must be conductance to produce two pole. It would be conductance. Okay, so we can see if we consider this what happened, these two conditions. So we will develop two pole low pass is called Butterworth. Butterworth filters. So it will be looking as usual. We have the capacitor here, and we have the voltage follower circuit. We have one resistor, and another capacitor here. So this will be the output. This is R1 is on by G1, R2 is on by G2, is C4 and C3, and this will be the input. Vi are on by G1, R2 on by G2, C3 and C4 V out. So in order to get the low pass filter, we put Y1 equals to G1 equals to 1 by R1. Y2 equals to G2 is equals to 1 by R2. And Y3 is equals to SC3. And Y4 is equals to SC4. And then they construct this circuit. So what will be the transfer function? From our previous developed transfer function, we can directly get the transfer function here. The V0S divided by VIS is equals to, if we replaced Y1, Y2, Y3, Y4 in this way, it will be G1, G2 divided by G1, G2 plus SC4. SC4 into G1, G2, G3. It will be the transfer function for this two pole low pass filter, and then
স্যার C3 হবে না?
G.
C3
Oh, sorry, G3 পরিবর্তে, হ্যাঁ, exactly. Instead of G3, it is not G3. Sorry, it will be SC3. SC3, exactly. SC3. Okay, then now if we consider the low frequency at zero frequency, at zero frequency, what will happen? S is equal to j omega is equal to 0. So the value will be, magnitude will be what?
1, sir.
1. Is it? Because this term will be 0. So G1, G2 divided by G1, G2. And then if you consider high frequency, S equals to j omega equals to infinity, what will happen?
Zero.
Zero. It will be 0. So the magnitude is 1 at low frequency and 0 at high frequency. What does it mean? You can see here, if it is omega, it is t. So at zero frequency, it has a magnitude 1, and at high frequency, it is 0, meaning you have the characteristics like this. So this is high, low pass, is it? Low frequency is passing and high frequency is blocking here. So it is the low pass characteristics. Okay, now there are several types of filter, but we will discuss here only the Butterworth type. It is on kind of filter. There are another special type filter. Sometimes we use is silent key filter. You can go through the document in internet. Is another silent key. This is another type of filter. It has also the general form. But what we have discussed, this is Butterworth filter. So this Butterworth filter is a maximally flat magnitude filter. That means the transfer function is designed such that the magnitude of the transfer function is as flat as possible within the passband. And this objective is achieved by taking the derivatives of the transfer function with respect to frequency and setting as many as possible equal to 0 at the center. Meaning, what we need to do, we need to make derivation and setting the magnitude will be 0 at omega equals to 0. So in order to more generalize, we can get let G1 equals to G2 equals to 1 by R. If we make this, then the transfer function will be changed accordingly. So from this transfer function, we can get the TS. If we replace G1, G2, we consider equal and both are R, then what will happen? The transfer function will be replaced by 1 over R square and 1 by R square plus SC4 into 2 by R plus SC3. Even we can more simplify it. It will be 1 over one plus SRC4 into 2 plus SR C3. And from here we can consider this RC4 a time constant and RC3 another time constant. So you can denote that RC4 is tau 4 and RC3 is tau 3, the two time constant. Okay, and also S is equal to what? J omega is always. Then we will have the transfer function Tj omega. Tj omega is equals to 1 over 1 plus j omega, and this is tau 4 into 2 plus j omega tau 3. J omega tau 3. Now in the denominator, if we make separation between real and imaginary, it will be look like this one. Real and imaginary separation. The top is 1 and the bottom is 1 minus omega square tau 3 tau 4 and plus j twice omega tau 4. Then since we have separated the real and imaginary, we can easily calculate the magnitude of the transfer function. Is it? So the magnitude will be Tj omega. The magnitude will be 1 minus omega square tau 3 tau 4 whole square plus 2 omega tau 4 whole square, and then minus half. So the magnitude of the transfer function will be this one. And then according to the maximally flat Butterworth filter, which indicate that you should have the derivative of the transfer function means dt by with respect to frequency dw. We need to derivative the transfer function magnitude with respect to omega, and then we need to put omega equals to 0. And at omega equals to 0, the magnitude will be 0. This is the condition. So in order to make this condition, we need to find out this dt by d omega. So if we go to the other slide.
So এই যেখানে ট্রান্সফার সেখানে যে বলছেন যে ট্রান্সফার ফাংশনটা ফ্ল্যাট হতে হবে, সো লাইক মানে এটা কি বোর্ড প্লটটা ফ্ল্যাট হতে হবে নাকি লাইক ট্রান্সফার ফাংশনটাই ফ্ল্যাট হতে হবে?
বুঝিনি, আরেকবার বলো।
লাইক আমরা যখন বোর্ড প্লট করি তখন তো আমরা লগারিদম নিয়ে নিই না?
হ্যাঁ হ্যাঁ।
সো এখানে আমরা লগারিদম কি নিব তারপরে কি ডিফারেন্সিয়েট
না
করব?
না 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 লগারিদম দেব না, লগারিদম নিচ্ছি না।
ওকে, ঠিক আছে।
লগারিদম নিচ্ছি না, যে ইকুয়েশন আমরা পাইছি সেটাই the equation which we get, we make the derivation that equation with respect to omega.
So we don't need to ensure that the board plot is flat. We need to ensure just the transfer function is flat.
Exactly. So what we will do, we make the derivative of the magnitude of the transfer function. So if we write the equation, the d in terms of omega, So if it is in terms of omega, then we can make the derivative. It will be half 1 minus omega square tau 3 tau 4 whole square plus 2 omega tau 4 square. Then e power minus 3 by 2, and then we make the internal part. If we make the derivative of this part, it will be minus 4 omega tau 3 tau 4 into 1 minus omega square tau 3 tau 4 plus 8 omega tau 4 square. And basically we need to make it equals to 0, is it? If we make it, it is equals to 0, and also sometimes at the same time we make omega equals to 0. So if you consider this is 0, then there is a two factor here. This one factor, this is another factor. If you consider this is x, this is y, then we can say simply xy equals to 0. If xy equals to 0, meaning either x is equal to 0, what is happening, or y equals to 0, either one. So we consider that y equals to 0. If y equals to 0, maybe x not equals to 0. If x not equals to 0, so we can write that minus 4 omega tau 3 tau 4 into 1 minus omega square tau 3 tau 4 plus 8 omega tau 4 square. Even we have another condition here, omega equals to 0. Then it is equals to 0. If we make simplify it, then we can write 4 omega, we can take common, 4 omega tau 4, 4 omega tau 4. So 4 omega, the 4 omega tau 4, then it will be minus tau 3, 1 minus omega square tau 3 tau 4 plus 2 tau 4, 2 tau 4 equals to 0. So again, this is one factor and this is another factor. So we can say that this is equals to 0, and if this is equals to 0, then we can reach a condition of 2 tau 4, 2 tau 4 equals to tau 3. This is the condition to make this function equals to 0. And if it is the condition, then from our previous value, if we put tau 4 is what? RC4, is it? RC4 equal to RC3. So from here we can have 2C4 is equals to C3. So the capacitor C3 will be double of capacitor C4 in our circuit, okay, in order to get the two-pole low pass filter. This is one condition, that the capacitor C3 will be double of the C4. And if we make this condition, then the magnitude will be changed as well. So the magnitude will be T will be like this: 1 plus 4 omega tau 4 to the power 4 and a half, like this. And also, if we want to find out the 3 dB or the cutoff frequency, then what condition we need? At 3 dB frequency, we know the magnitude is root 2.
1 by root 2.
1 by root 2. In this case, magnitude will be 1 by root 2. So if we put this condition 1 over, okay, we can write here 1 over root 2. So in order to make this term will be what? We need to make it 1. Is it or not?
Yes, sir.
Yes. So we can write that 4 3 dB. So we can write omega 3 dB tau 4 to the power 4 is equals to 1. At 3 dB frequency, this condition will be fulfilled. So from here we can find out the okay, if we write omega 3 dB is equals to twice pi f3 dB, and this is equals to 1 over tau 4 root 2, tau 4 root 2. So basically it will be 1 over root 2 RC4. But in general, we usually write omega 3 dB is 1 over RC. 1 over RC. The 3 dB frequency. So if we accumulate all these three equation, then from here we can find that C4 will be 0.707 C. And if it is so, then the C3 will be double of this. Double means 1.414 C. So in order to get the low pass filter, we should have this capacitance value. And if we find this capacitance value, then the circuit will be changed accordingly. The circuit will be look like this. If we draw the circuit, the voltage follower, capacitance C4, the C4 is equals to 0.707 C, and it will be a R. Another capacitor C3 will be 1.414 C. Bi, it is R, which is R. So these two is equal R, and then C3, C4. So, and its corresponding transfer function will be look like this one. If it is F, it is Tj omega. Then the magnitude curve will be look like this one. So it is unity, and the cutoff F3 dB. F3 dB is 1 over twice pi RC. Okay, what will be the slope of this line? Can anyone say it? Hello?
Yes, 6 decibel.
6?
Yes, sir.
Why 6? The 6 was for the single pole,
Oh, yes,
but
sir. 40
here,
হবে তাহলে। For
huh?
40 dB, বলে 40
Exactly,
dB
it
per
will be
decibel.
minus 12 dB per octave or minus 40 dB per decade, because is the second order double pole, is it? There was a power n, 6n or 20n, 6n dB per octave or 20n dB per decade. The n was the number of pole, basically pole or zero. So since here is double pole, meaning 12, 6n means 6 multiplied by 2, so 12 dB per octave or 40 dB per decade. And then accordingly the magnitude, the transfer function magnitude will be look like this. The magnitude is 1 over 1 plus f divided by f3 dB to the power 4 and a root over there in terms of 3 dB frequency. Okay, so the transfer function of 2 pole low pass for the low pass, and in the same way we can drive the characteristics of the high pass filter as well. So in order to get the high pass filter, simply if we change the place of the capacitor and the resistor, we will have the high pass filter. So how we can find? In that case, we can go, if we will find the high pass, in order to get the high pass, we need to make it capacitor. This is also capacitor, and the R3 will be vice versa 0.707, and R4 will be 1.414 R. And for this, the corresponding transfer function will be look like this one. If it is omega, it is t, then your transfer function will be look like this. And the corner frequency or 3 dB frequency, f3 dB is equals to 1 over twice pi RC, and the magnitude will be here 1. So what will be the slope of this line?
I think so 40 dB per decade.
Plus for 12 dB per octave or plus 40 dB per octave, dB per decade. So if you want to make it more sharper, then what you need to do? You need to increase the number of pole. Okay, you need to increase the number of pole.
স্যার
Yes, please.
স্যার এই যে ওমেগা অ্যাট ওমেগা ইকুয়াল টু 0 আমি ডেরিভেশনটাকে 0 করলে ফ্ল্যাট লাইন কেন পাচ্ছি স্যার?
বুঝনে কোন কথাটা বললাম?
সেই যে মানে
maximally flat.
ইয়েস স্যার।
Actually that one is the developed condition. If you follow this, then it will provide you the maximally flat, because provide that condition means the it is make as much as possible zero from the transfer function. So automatically from the board plot you can see, if you make more zero on the transfer function, then the magnitude of the pass band will be more flat. and that one we didn't drive. We just consider that condition from the Butterworth filter. Okay, then if we get this second order high pass filter, then for the high pass filter the magnitude will be look like this, just reverse of this one. So if one derivative of the, it will be f3 dB by f to the power 4. This will be the magnitude for the high pass one, high pass filter. High pass filter. Even if you simulate the basic equation without that condition, the dt by d omega equals to 0, if you simulate with the computer, you can easily differentiate both the transfer function, you know. এই কে জিজ্ঞেস করলা যে স্যার এটা ম্যাক্সিমালি ফ্ল্যাট হয় কেন, তুমি এই এক্সাক্ট ভ্যালু গুলা কম্পিউটার সিমুলেশন করলে তুমি ডিফারেন্সিয়েট করতে পারবা, বুঝছো?
জি
before minimization using the derivation, if you simulate it, then you can see the differentiation between maximally flat and the closed one. So for the high pass it will be this one, and using the same structure we can further go in higher order, because it's up to second order, but using the same structure we can go for the third order, fourth order, because is depends on the number of pole. If the number of pole is n, so for the n pole active low pass filter, the roll off will be n into 6 dB per octave. So if it is n equals to 2, in these two case n equals to 2, is it? N equals to 2 here, n equals to 2 here, 2 here, n equals to 2 here, 2 here. So if n equals to make 3, what will happen? It will be 60 dB per decade. So it will be more reduced, like this one, and this will be this one. And then if you make n equals to 4, it will be more reduced. It will be more reduced. In this way, you can make the roll off more sharper according to number of pole. But in the higher order of filter, there are some other limitation as well. But in this way, we can develop a higher order filter as well. So for the higher order filter, then we can say that the magnitude, basically you can say that this is 2n, is it? 2n, number of pole is depend on number of pole for the higher order. Maybe if you go for one further higher order, maybe in case of 3, you need another RC portion here. Okay, then if you go further order of 4, then you should need another RC structure before this one. But at the same times, if you do not use the buffer circuit, there will be loading effect, is it? So in order to reduce the loading effect, we can provide the buffer circuit again and again. Okay, I am not going to the higher order now. So for the time being, you can conclude up to second order. Okay, up to second order. Is it okay?
yes sir.
And at the same times, if you go through the internet, you can find another kind of filter is called Sallen key. I think Sallen key. You can go through this also. This is another special type of general structure. Using the silent key structure, also you can develop second order, third order, fourth order, low pass, high pass, band reject. All you can design from this one, silent key. Okay. So maybe I can conclude my discussion here, and then if you want more, we can discuss on the on Sunday after class, Sunday after quiz.
স্যার কুইজের সিলেবাস স্যার শুধু ফ্রিকোয়েন্সি রেসপন্স
সিলেবাস কুইজের সিলেবাসটা আজকে পর্যন্ত নিতে চাইছিলাম, তো তোমাদের আরেকটা সেকশন আবার আজকের ক্লাসটা বাদ দিতে বলছে। সো দ্য সিলেবাস অফ কুইজ উইল বি এক্সক্লুড টুডেজ লেকচার।
স্যার আগের দিনের লেকচার পর্যন্ত,
আগের দিনের লেকচার
এর আগের দিনের লেকচার পর্যন্ত নাকি?
বুঝি নাই, গতকাল পর্যন্ত রাখছি।
হ্যাঁ গতকাল পর্যন্ত এটাই।
কুইজ উইল বি কভার আপ টু লাস্ট লেকচার, I mean up to first order filter. The second order filter will be excluded.
স্যার স্যালেন কি কোথা থেকে পড়বো স্যার?
এটা তুমি একটু ওয়েবসাইটে সার্চ দিয়ে ইন্টারনেটে দেখবা যে এই মুহূর্তে আমার কাছে নাই, এটা আইটি তে রয়ে গেছে আর কি ডকুমেন্টসটা, বাট ইউ ক্যান গেট ইট অ্যাভেলেবল অন দ্য ইন্টারনেট।
ওকে স্যার।
Assalamu alaikum, sir. Sir, I'm 111. Sir, I missed my attendance.
এই এত বেশি তুমি 111 প্রায়ই মনে হয় দেরি করো না?
No, sir. Today is my first day. I joined a bit late.
এই মনিজা আলম মানবী, আমার খাতাতে কিন্তু সব নোট করা থাকে, আমি জানি তুমি লেট করছো এর আগে। এনিওয়ে দিয়ে দিলাম, কিন্তু লেট করা যাবে না। হ্যাঁ
Sir, assalamu alaikum.
ওয়ালাইকুম সালাম।
Sir, 134. I was also late, sir.
ওকে, 134 ও লেট করেই আসে। আমার খাতায় কিন্তু সবকিছু নোট করা থাকে, বুঝছো? এই বলবা যে স্যার না আমি তো কখনো লেট করিনি, এরকম বলবা না, কারণ এটা বলে তো তোমার লাভ নাই, শুধু একটা মিথ্যা কথা অ্যাড হবে তোমার সাথে, বুঝছো না?
Yes,
কারণ আমি
sir.
তোমার সম্বন্ধে সবকিছু বলতে পারবো, বলার দরকার নাই যে স্যার আমি লেট করি না। তুমি যে লেট করছো কয়দিন সেটা আমার খাতাতে নোট করা আছে, ঠিক আছে? ওকে, সো বেস্ট অফ লাক। ওয়ালাইকুম সালাম ওয়া রাহমাতুল্লাহ। হার্ট ফেল করবে তো, হার্ট ফেল